Good morning, everybody. Let's start this day off right. I have the answers before you. So these are all the answers for the Law of Sines assignment. Pause it, use them, check your answers. Feel free to go back and do the problems again if you were a little stuck. So let's go ahead and get started. I want to finish off this chapter. I have one more lesson to take care of, and that's what I plan to do today. So once again, get your scientific calculators out. I'm going to use my phone because that's all I got. And turning it sideways right now. Here we go. Let's get rocking and let's get rolling. So go ahead and title your notes 8.6b. The law of, well, we already did the law of sines. Let's do the law of cosines. Okay. Well, here's the law of cosines, everybody. Here it is. In any triangle, ABC, where little a, little b, and little c are the sides. Okay, here comes the equation. But you know what? Let's go ahead and draw a picture first. It says triangle ABC. It doesn't say right triangle ABC. So once again, 8.6, the law of cosines, and then the previous lesson, the law of sines, works with non-right triangles. So let's draw a non-right triangle. Draw a triangle that's not right. How about that? Maybe that's a little easier to understand. A triangle that's not right. A, B, C. And then little a would be across from big A, little c would be across from big C. You guys get the idea. Okay, here's the law of cosines, everybody. In triangle ABC, where little a, little b, and little c are the sides, this is a tougher equation than the law of sines. It starts out like this. A squared equals b squared plus c squared. Kinda looks like a familiar equation. It looks like the Pythagorean theorem. We know the Pythagorean theorem. Oh, I'm not done with this, by the way. But we know the Pythagorean theorem is a squared plus b squared equals c squared. So yeah, it kind of looks like the Pythagorean theorem, but we're not done with it. Minus 2bc cosine of big A. I told you this is different than the law of sines. This equation is much more difficult. I'm going to show you how to work with it. And yes, you do need to have it memorized. Let me say that again. You need to have this memorized. Let me give you some pointers, some tricks that I remember. Because I got it memorized and it's really not that bad. First thing you need to know. Whatever these two are, for example, it's the B and the C, are always going to be the same thing here. So BC, BC. And one more thing. Whatever this letter is, that's going to be the angle that you're trying to find. Those are always the same. And then, of course, you got to remember this minus 2 right here. And the cosine, because it is, after all, the law of cosine. So there she is. That's the first equation, everybody. There's a second equation and a third equation. Oh, how lovely, right? Here we go. B squared equals A squared plus C squared. Looks like the Pythagorean theorem, folks. Notice how I'm just switching the A and the B. It's practically the same thing. Minus, think about this with me. 2, what goes here and here? If you were just listening, whatever these two are, goes here and here. So minus 2AC cosine of, come on, you know it, big B. Because these two are always the same, and AC are right there. My brother is texting me. Why are you texting me? Leave me alone. Okay. Sorry, everybody. I'll yell at him later. Last equation. C squared equals A squared plus B squared. That is the Pythagorean theorem. It's the same thing. Minus 2 AB cosine of big C. Alright, I'm gonna highlight all these. That's what we're learning today. Let's throw a little cloud around it. Everybody, here's the lesson. And Time for an example. Time for example. I need to show you how to use this. So, let me flip the page. Alright, example 1. Let me make sure I'm looking at the right notes here. I would like you to find little a. And I'd like you to round to the nearest tenth. Move this up. Here we go. B, B, B. Big A, big B, big C. Notice how I said big B right here. I didn't say Dunkin', and I didn't say Starbucks. It's big B. Oh, joke for you. Throw some humor your way on these coronavirus days. That's 11. We're going to say that this is 25. And I'm going to say this is 67 degrees. We'll put the little a right here. Perfect. Perfect. Now, before we use here, let's rip this off because I want to reference it. Okay. Before we use this equation, and we're going to use this equation, I want you to see why we cannot use the law of sines. So, off on the side, could you put the law of sines? Go ahead and write this in your notes. Hopefully you remember what it is. It's the, let's see, the sine of big A all over little a equals, well, you can do the sine of big B all over little b, or you can do the sine of big C all over little c. I'm going to choose to do, because we have, well, what do we have? Well, here, let's just try this. You can do the sine of big B all over little b. If you tried to get this to work, I don't think it's going to work. Check this out. The sine of 67 degrees, that's big A, all over little a. So that is what you are trying to find. That's what we've got. Now, if you remember from last lesson, we need to have 3 of the 4 components. Let's do the sine of big B. Here's a problem. Do you have big B? No, you don't. You don't even have big C. Do you have little b? Yeah, you do. I should have actually put little b right in there, 25. So we have the 25, and we have the 67 degrees, but notice how we have 2 variables that are unknown. So, you know, maybe we work with the c's. Let's try the sine of big A all over little a equals the sine of big C all over little c. See if this works. Sine of big A, 67 degrees, all over little a, equals the sine of big C. Gosh darn it. We don't have it. We have little c. It's 11. Once again, you have 2 of the 4 components. And in order for the law of sines to actually work, you need all 3. You need 3 of the 4. So, sorry, that's not going to work. That's not going to work. So, the law of sines... Okay, I need to turn my... Alright, it's vibrated. I need to turn... Well, I got to turn my phone off. So, the law of sines is not going to work, everybody. We are forced to use the law of cosines. So, let's give this a shot. Notice how we are trying to find little a. So, trying to find little a. Which of these equations are we going to use? Just think about it real quick. What else do we have? Let's see. We have big A. It's 67 degrees. We have little b, which is across from big B. It's 25 inches or miles or yards. I'm just going to keep it as 25. And we have little c. It's 11. So I'm looking at it right away. We have one angle, 67 degrees. We have big A. The only one that really makes sense is the first equation, because that's the only one that has a big A. There's no big A's here, there's no big A's there, so we're going to use the first equation. Let me go ahead and write it down. A squared equals b squared plus c squared minus 2bc cosine of big A. Now, go ahead and plug everything in that you have, and we'll see what we get. A squared equals, there's your unknown, b squared, 25 squared, plus c squared, 11 squared, minus 2. Now this is multiplication here, everybody. So we're going to multiply the 2 and the b and the c together. So the b is 25, the c is 11, times, once again, there's multiplication here. So you're multiplying all these together, times the cosine of big A. Okay. to take this nice and slow. I'll go fast on my next problem. But there's your variable that you're trying to find. I've highlighted it in my red pen. And everything that we've plugged in, we plugged in the 25, plugged in the 11. That 2 was already there. Plugged in the 25 and the 11 and the 67. Everything has been plugged in, and we only have one variable. So let's solve. First things first, I'm looking at this, and you can evaluate that, and you can evaluate that. If you want to punch it in your calculator, feel free. But 25 times 25 is 625. And 11 times 11, shoot, all of you should know that. Minus. This is multiplication. Go ahead and multiply those three numbers. I do not know what that is. I don't need to turn it sideways. Let's go 2 times 25. There's your 50 times 11. So it's 550. And once again, it's times the cosine of 67 degrees. All right, a couple things that we know how to do. We know how to work with squares, and then we know how to multiply. So that's, here, we'll draw a little arrow to kind of show you what we got there. All right, next step. We've got to keep simplifying. I got to solve for the a here. Go ahead and combine these like terms. They're numbers. So a squared equals, what is that, 746 minus 550 cosine of 67 degrees. Okay. It's getting a little simpler. We're making it a little easier. Next step. Now, this is what I want to show you not to do, everybody. I'm going to write this big in my notes. Not. Do not. Do not subtract those. That is what we call bad math. That is what we call illegal algebra. You're not allowed to subtract those if we have multiplication right here. It's kind of like if we did this. I'm going to come off on the side. Don't write this down if you don't need to. But if you had 746 minus 550 times x, there's multiplication right there between the 550 and the x. Are you allowed to subtract these? Oh gosh, I hope not. If you said, yeah, subtract them, please go back to Algebra 1 and retake that class. You're not allowed. 746 minus 550. Okay, this is sad. I'm going to have to punch that out. Okay. Gives you 196. You can do a number minus a number. You can do 746x minus 550x, and that's going to give you 196x. That's okay, and that's okay. However, this you just can't do. Please do not combine those together. So I'm going to rewrite this now that we all know what not to do. Cosine of 67 degrees. I just rewrote it. The question is, what do we do from here? Well, if you can't combine these, then we're going to have to multiply these two together. Now keep in mind, the cosine of 67 is just a decimal. It's a decimal in your calculator. So let me get this up. Cosine of 67, man, that is bright. Okay, here we go. 67 times the cosine. So everybody, there's the cosine of 67. 0.39 and a whole lot of numbers. I'm going to multiply that by 550. And I'm getting 214.9, roughly. So a squared equals 746 minus 214.9. Now, ideally, I wish I could just keep this in my calculator because it's going to give me a more exact answer. However, that's pretty close to 214.9. If I just lost that 0 to 1, to, everything, that's fine. It's going to give me a close enough answer. Okay. Next step, let's take 746 minus the 214. So, here we go. 746 minus 214.9. And your a squared equals 531.1. And the very last step you need to do is to square root both sides.